Now we have a new function. We have done constant function. We have done identity function. And now we are starting with modulus function. Fx is equal to modulus x. This is the function we have. And we want the graph of this to be plotted. So whenever modulus x comes, we should keep in mind x is less than 0. Whenever x is a negative number here, then in that case inside quantity will be negative. So 1, when you open modulus, it will come minus x. Second will be x greater than or equal to 0. Your answer come out to be x. So this is the modulus function we have, that whenever inside quantity is negative, one more minus will place to get it positive, and if it is greater than 0, then we'll say it is simply x. Now my question is how to plot this graph. In this case, when you plot the graph, check here, it's 0, 1, 2, 3, 4. Here also 1, 2, 3, 4. First I'm taking positive numbers here. Here it is minus 1, minus 2, minus 3, then comes minus 4. Here it is minus 1, minus 2, minus 3, and minus 4. Now check this. When you put 0, this will be the condition we are going to use. X, when you put 0, it will come out to be 0. So at 0, the curve will give 0. Then when you give x as 1, 1 means a positive number. So at modulus 1, it will be 1. So this is the result. At 2, it's 2. At 3, it's 3. Same way when you go for minus 1, modulus of minus 1, then what I should write, minus of minus 1 come out to be plus. So minus 1, it's 1. Minus 2, it's 2. Minus 3, it's 3. So now when you join it, you will get a straight line from this side and another straight line this side. This line we will be saying it's a positive side, so this says fx is equal to x, or I should say y is equal to x line, and this will be y is equal to minus x, because this is your y. So this will be the curve we are going to get here. In this case, if I ask what is domain of the function, we will say either plus value you take on x or you take minus value on x. So this come out to be going to define. So we will say domain of the function is all the real number. Codomain of function, always we have real number. But when you think about the range of the function, just check. Y will give you range, means whatever the value it will take always a positive value, never take negative. X you take plus, it is always plus. Y you take x you take negative, again y is plus. So as the graph is going above x-axis, it shows that y is always positive. Y is positive means the range come out to be positive. So we will say range of the function will be R positive union 0. Third condition, this curve we can plot. It's a V-shaped curve, and this curve is going to plot without lifting your pen or pencil. So we will say this will be the curve. We will be having shape V. So this curve will be a continuous curve. Everywhere it will be continuous. So I should say it will be continuous curve. Continuous everywhere. Everywhere means it should be continuous for all the real numbers. That you should keep in mind. Now, second thing, is it differentiable? Differentiability, I told you, it is going to break when there is a corner point. Is it a corner point possible here? Yes. It's the V curve, so this will be a sharp corner we have. So at this point, the differentiability fails. So we will say this function is not differentiable everywhere. Or you should say it is differentiable everywhere except at x is equal to 0. So we will say this function is differentiable everywhere except at x is equal to 0. So at x is equal to 0, this will be not differentiable. So we will say modulus x is not differentiable everywhere. It will be differentiable everywhere except x equal to 0. So there is one point where the function is not differentiable. So we can't say it is everywhere continuous, everywhere differentiable. We'll say it is everywhere continuous, but not everywhere differentiable. Where it is not differentiable, it is at x is equal to 0, it is not differentiable. So now you should plot this curve. Whenever modulus curve, keep in mind the shape of the curve always come out to be a V curve. That curve will be continuous, and at the same time it will not be differentiable at one point, what that point where this function becomes 0. Now I'll take one more example of this. Just check here. By the way, if I say it is modulus of x minus 2, when you have the function y is equal to modulus of x minus 2, then what change will be there in this modulus when you open? It will come out to be x minus 2 is less than 0 and x minus 2 will be greater than or equal to 0. Whenever this quantity comes out to be negative, I should say it is minus of x minus 2. And when x minus 2 is a positive, this number come out to be x minus 2. And when you plot this curve, this is changing at 2. X is less than 2, you can write for it. It is x is greater than or equal to 2. So where it is changing its value? At 2 it is changing its value. So it is 1 and it is 2. So at 2 you will be having your V. So the curve comes out to be this way. At 2 you will find there will be a corner point. Other places it will be a line. And this side you should say it will be y is equal to minus of x minus 2, negative side. And for positive it will be y is equal to x minus 2. So keep in mind this function is continuous again everywhere, but differentiable everywhere except what is there? 2 is the point where it will not be differentiable. So function is continuous everywhere but not differentiable at x is equal to 2. That you should keep in mind. So this value, wherever it comes 0, that value will be the point where the function will fail differentiability. By the way, if it is modulus of 2x minus 3, then we will say it will be continuous everywhere. Where differentiability fails, at x is 3 by 2. Equate this is equal to 0, then whatever x value, that will tell you that this is the point where the function is not differentiable. So keep in mind this function will be continuous everywhere, differentiable everywhere except at one point x is equal to 2. In this case it is x is equal to 3 by 2. So this is the another function we have called as modulus function. Now coming on next function, greatest integer function. Next function is greatest integer function. Greatest integer function, also called as step function. Okay, this is also called as step function. Also called as, first I'll define it, fx will be, the symbol for this function will be fx is greatest integer x. This is the symbol for greatest integer. It is also called as floor function. How this function defined, that you should keep in mind first. How this function defined? This function totally depend on the value inside it. If I just take a number line, this point is 0, 1, 2, here it is minus 1, minus 2. What this function says, this function is defined such a way that whatever real number you are taking, in that real number, whatever the greatest integer includes will be my answer. I repeat it. This function gives greatest integer function. Why it is called? Because whatever real number you take, in that real number, whatever the maximum or the greatest integer includes will be the answer of this function. For example, if I say you write down f of 1.5, greatest integer 1.5. So 1.5 greatest integer I want. 1.5 will be somewhere here. When you take 1.5 is somewhere here, then what you will find, this point will have the integer 1 also. It will be 0 included, minus 1 included, minus 2. These all integers are included in this number. 2 are above, 2, 3, 4, they are above it. But we will say this will be having the integers included in this number will be 1, 0, minus 1, minus 2. These are the numbers included in it. So whenever it is included in it, then whatever the number which is, or whatever the integer greatest among all, that greatest number will be 1 in this case, integer. So we will say it will come out to be 1. By the way, if I say f of 0.2, then where is 0.2? It will be somewhere here. What integer it include? 0, minus 1, minus 2, and among them, which is the greatest? 0. So we will say 0.2, your answer is 0. Same way if I say f of minus 1.3, where is minus 1.3? Minus 1.3 will come here. When you go for minus of 1.3, the integers which will include these, what is the integers? It will be minus 2 included in, minus 3 included, minus 4 included, and greatest one is the minus 2. So your answer come out to be minus 2. So whenever you want the greatest integer value, only the thing what you should do, you put them on number line, that point. Then whatever its first left integer, whatever the position, for example, if it is 1.5, 1.5 is marked here, which is the first integer 1. When you take 0.2, it is included here, first integer 0. When minus 1.3 is here, first integer is minus 2. So we will say whatever the first left integer, that is the lower side we are going. So whatever the first integer, lower side, will be giving the answer. And that's why this function also called as floor function. Floor, why? Because we are going towards the lower side. That is the floor, lower floor. Above side we'll go, that will be roof. Okay, or ceiling. So in this case, ceiling, floor. So this function will be called as a floor function also. It is called a step function because its graph come out to be like a step. So that's why we will call that as a step function. Now, if you want to plot this graph, just check, very important one. Its graph is like this. This is 0, this is 1, this is 2, this is 3. Here it comes minus 1, minus 2, minus 3. Here it comes 1, 2, 3. Minus 1, minus 2, minus 3. And one more thing, if I say greatest integer at number 0, for example 0, then 0 itself will be the greatest. So at 0, the answer come out to be 0. When you go for 0.1, now I am going on 0.1. 0.1 means somewhere here. So what is the first left integer? 0. So at 0.1, your answer is 0. 0.2, your answer is 0. 0.3, your answer is 0. So this line continues till 0.999. Till 0.999, you will find your answer will be 0. 0.99999, you go, still 0. But as soon as you reach to 1, your answer will be 1. So this line will continue, and this will continue till 1, and at 1 circle I am taking, that indicate that this line is going closer and closer to 1, but as soon 1 is there, it will jump to 1. Okay, then at 1, the value is 1. 1.1, what the answer is? 1. 1.2, answer is 1. 1.3, answer is 1. 1.4, answer is 1. As you reach 2, it jumped to 2. Then at 2, its answer is 2. 2.1, answer is 2. 2.3, answer is 2. So this will come 2, so on, and then when you reach to 3, it will jump to 3. Same way when you go for minus 1 your answer is minus 1. Then minus of zero point 0.8, it's minus 1. This will continue. And as soon as you got to 0, this value jumped to 0. Same way when you go for minus 2, your answer is minus 2, minus 1.9, it's minus 2, so on it will continue till minus. So here what you will be finding, these graphs, and this circle will be a hollow circle. That means this line is going nearer and nearer, but not going to touch it. So this will be the graph we are going to have for greatest integer function. And in this greatest integer function, what you are finding, this will be a step function. So that's why it is called as a step function also. Floor function I told you because we are taking the value from the lower side. What is the domain of this function? Domain of function, any real number I can place, I can get the answer. So real number is the domain. Codomain always remain real number. Then we go for range of the function. We should keep in mind that answer always come out to be an integer. So that's why we will say the range of the function will be integer. This function is discontinuous. You can't plot these steps without lifting your pen or pencil, so it will be discontinuous function. Where it is discontinuous, where it is going to break, at 1, at 2, at 3. So discontinuous at integers. That you should keep in mind. Between integer, yes, it is connected, but discontinuous at integers. And whenever the function is discontinuous, we are not concerned about differentiability. Differentiability only defined for continuous function. So we will say this function will be discontinuous at integers, and shape of this curve will be step function. Then these are the range I told you, I, and this way the function is going to define. So this is the greatest integer function. Next, we'll continue.